Today I'm going to start with fifth problem of exercise 8.4. So this says that this is actually prove the following. LHS given and you have to prove it is equal, both are equal. LHS equal to RHS. So let's see how to do it. So first I want to begin with a simple property here. Identity. It is algebraic identity, that is a minus b whole square is equivalent to a square minus 2ab plus b square. So now using this I can expand this, so it will come as cosecant square theta minus 2 into cosec theta into cot theta plus cot square cot theta whole square. So I'm taking only RHS. We are not bothered about LHS is left hand side. So now I am going to write in terms of sine and cos, because here the right hand side expression is in terms of cos. So now I am going to write in terms of sine and cos. Now we know that 1 by sine square theta is equal to cosecant square theta. So now I can write this way. So this will be 1 by sine square minus 2 into 2 by sine theta into cos by sine. Cot is cos by sine plus cot square is cos square theta by sine square theta. So this, now we can see the denominator is sine square. So I can take this as denominator is sine square and numerator is 1 plus cos square 1 minus 2 cos theta plus cos square cos theta square by sine square theta. So now if you clearly observe, if you try to observe how we can simplify further here. So we know that I have already mentioned this identity, a minus b whole square is equal to a square minus 2ab plus b square. So now if I consider a as 1 and b as cos theta here. So if I try to expand this 1 minus cos theta whole square, here what will happen? Let's check whether it will match with our numerator or not. So 1 square minus 2 into 1 into cos theta plus cos square theta. So you can observe that this is equal to 1 minus 2 cos theta plus cos square theta. So this is very evident that this is matching the numerator, and also similarly from the identity sine square theta plus cos square theta is equal to 1. I can use it and write sine square in terms of cos. Why? Because here right hand side we have only cos terms. So we want to reduce everything in terms of cos. So sine square theta is equivalent to 1 minus cos square theta. So this, now if I substitute in this equation, it will become 1 minus cos theta whole square by, this is whole square, by 1 minus cos square theta. So now after seeing this, now further how we'll simplify it. We know the identity. We know the algebraic identity. Again, these three identities are very important algebraic identities. A square minus b square is equal to a plus b into a minus b. A plus b into a minus b. So now here I can write this 1 square minus cos square in terms of this. If I write it, then it will become 1 minus cos theta whole square. Remember, this is the whole square, and in the denominator I can write it as 1 minus 1 plus cos theta into 1 minus cos theta. So if I write like this, then what will happen? You can clear both the numerator and denominator terms are same, but numerator is squared, so I will cut this, I'll cancel this and square will be cancelled. So the remaining term, will be the remaining term. Now I can write it below. Remaining term will be the RHS. It is very evident that what I am saying, which is equivalent to 1 minus cos theta in the numerator by 1 plus cos theta. So this is equal to RHS. The RHS is nothing but right hand side. So this we have completed this problem with this. We always that one suggestion is that when you don't get the answer in the first attempt or when you try, don't get panic. So we have to try on different various methods. So if you practice with the practice, you will understand when to use which one substitution. So now I am going to start with the next question. So second question. Second question is nothing but cos A by 1 plus sin A plus sin A plus 1 plus sin A by cos A. 1 plus sin of A by cos A. So now I am writing like this, equal to, we have to prove right hand side is equal to 2 into secant of A. So this is A, secant of A. So now I am going to how again. We will begin by taking LCM. There are no common terms, so I have to multiply it directly. With this term I have to multiply cos A, and this one I have to multiply 1 plus sin A. So if I multiply it, then it is cos square A. Cos A into cos A is cos square A plus again, so 1 plus sin A. I'll put a bracket here. It is 1 plus sin A into 1 plus sin A by 1 plus sin A into cos A. So let's simplify the numerator, and now we know that this one, if I take cos 1 by cos theta, we got the secant theta. So secant, sorry, this should be A, it's a mistake. So cos A. So now if I use it, now what to do? I am not going to simplify the numerator because we already got the sec of A. Because here cos A is in the denominator. So 1 by cos A is nothing but sec A. So we'll try to simplify the numerator and see whether we can cancel it or not. So I'll expand the bracket now. Expand the bracket. So cos square a plus 1 into everything again, same thing will repeat. 1 plus sine a plus, now I'll write sine a plus sine a into 1 plus sine a into sine a is sine square a. So this is the terms we got, and then I can write 1 into 1 plus sine a. Okay, so this is what is there, 1 plus sine a into 1 plus sine a into cos a. So denominator we are not touching it for the time being. So now we know that cos square plus sine square is 1. So I'll directly write 1. So 1 plus sine a plus sine a is 2 sine a. So let me write here itself, 1 plus 1 is nothing but 2. So I'll directly write here 2. So now if I write here 2 plus 2 sine theta, denominator is there, 1 plus sine a by cos a. So now it would have been noticed that why I didn't simplify it. So I'm using this identity to get the 1 in the numerator. We know that cos square a plus sine square a is equivalent to 1. So this is identity. So now I am going to take 2 common in the numerator. 2 if I take common, then it will be 1 plus sine a, because you can check it up. If I multiply, you will get 2 into 1 is 2 and then 2 sine a. So now denominator is already 1 plus sine a into cos a. So now these both terms are same, so I can cancel it. So cancelling is nothing but, if there is a value in the numerator x and x by x is nothing but 1. So both the terms are same, then you can cancel it. So it will be 2 by cos a, which is nothing but, if I take cos a in the numerator, it will become sec. So this is that. So hence it is proved. So now I am going to start with the third question. This question is slightly complicated. So what is asked here? The third part is tan theta by 1 minus cot theta plus cot theta by 1 minus tan theta is equivalent to 1 plus secant theta into cosecant theta. So this is asked to prove. So now how we'll go? As you've seen in the textbook, that hint is given that write this expression in terms of sine and cos. So we will try to do the same. So as I mentioned in the beginning from the first problem itself, that always try to, if you don't know anything what to do, try to bring in terms of sine and cos, because that is simpler to simplify. So now I'm going to bring it as numerator. Now it will be little bit messy here, so I'll write tan theta, I'll write as sine theta divided by cos theta by 1 minus sine cos theta by sine theta. Cot is nothing but cos theta by sin theta. So plus, again I will write in this form. Numerator will be cot theta. So cos theta by sin theta. So this is there. And then 1 minus sin theta by cos theta. So now this expression is looking very complex, little bit complex at least. So now how to solve it? I'll try to take the LCM in the denominator. We'll take the LCM in the denominator. So let's see what happens. So if I take LCM, then 1 into sin theta will be, if I take start here, let I go 1 into, let it be sin theta by cos theta divided by sin theta minus cos theta by it should be sin theta. Now this is a different, so always try to put the bracket for numerator and denominator separately, because this you should have, because there are so many divisions, so you might get confused. So now again this side, if I take LCM, cos theta by sin theta, so cos theta will go into 1 cos theta minus sin theta by cos theta. So this I am taking it. So you have been familiar with fractions, right? We would have been learned that if it is A by B divided by C by D, a form, fraction can be written as nothing but A by B into D by C. So there are, you can only, that this side which is their expression divisor should be inversed. So this is what I am going to follow here. Let us consider that this is A. For example, this is A and this is B. So I want to divide. Sorry. This is A, B, and this is C and D. So I want to divide AB divided by CD. So now I have to, in this form, if I write, what I will get is, just carefully follow it, this step. Then what will happen is that A divided by B divided by C. So C by D. So A divided by B into D by C. I can directly write like this. This should be coming. A by B will remain same. That is sin theta by cos theta will remain same. So now I will, in the denominator, I have to inverse it. Denominator I have to write in a reverse manner. So this will become sin theta into sin theta by sin theta minus cos theta. So this is the case. Similarly, I can write for plus cos theta. I can write it cos theta by sin theta into cos theta by cos. So now I want to take the minus sign common here. Let me take the minus sign common. So no need. Because I want the denominator should be same. So if I take minus here, it will be sin theta minus cos theta minus. So this is the case. So now again I am continuing here. So little bit messy. Again here, if you check the numerator, here sin theta is there, here cos theta is there, but these terms are same. So sin theta minus cos theta is same. So I have to multiply this side, right? This one by cos theta, this one by cos theta, and this one by sin theta. So doing that, already in the numerator sine square is there. Sine into sine is sine square. So again if I multiply with sine, it will become sine cube, and then I'm writing, because the numerator will be, denominator will be same. So again if I multiply with cos, it will be, already it is cos square, so it will become cos cube theta by sine theta cos theta. I can write this as cos theta sine theta, cos theta into sine theta into sine theta minus cos theta. So now till now it's everything is right, but now how to proceed? So you may have come across this formula. I am writing this here, or at least if you have not come across, a cube minus b cube can be written as a minus b into a square plus ab plus b square. So how I am going to, I'll just prove it. I don't want to like you remember the result. Just simply it is a minus b. So if a into a square is a cube, and then a square b plus ab square. Similarly minus b into a square minus ab square minus minus a square b. It should be minus a square b. Minus a square b and minus ab square minus ab square minus b cube. So now these terms are like terms, and plus minus cancel and minus cancel. So this a minus b cube will be remaining. So this is a formula. So that's why some algebraic identities you have to remember. So this one, if I write in this form, so let's see what will happen. It is a is sine theta and b is cos theta here. So I can write sine theta minus cos theta. So you can observe that now the denominator has one term, so I can cancel this both. A square is a is sine theta, so a sine square, a square is nothing but sine square. Then I will write b square here. B square is nothing but cos square, then plus ab plus sine theta into cos theta. So I can write like this. So this will become as, now I will cancel. I will cancel the numerator and denominator term. Cos theta sine theta into sine theta minus cos theta. So these both terms are cancelled. So remaining is this turns out to be 1. So this will turn out to be, this is 1 using the identity. So thus so the numerator will become 1 plus, so the numerator will become 1 plus 1 plus sine theta cos theta. So this is a lengthy problem and little bit complex also. So cos theta into sine theta. Now we can see that if I split this up, I can write this as 1 by cos theta sine theta plus sine theta cos theta by cos theta sine theta. So this both are same, I can cancel them, and this is equivalent to 1. So now I will write this expression as, so remaining, what is remaining? So remaining is, if I take this both to the numerator, it will be secant theta into cosecant theta plus 1. So which is equal to RHS again. So this is very clear now that this problem how to proceed. and how to get the result required. So I'm going to continue other problems in next video. Thank you.